On June 17th, 2026, the first named storm of the Atlantic season formed just off the Texas coast. Forecasters had a plain message from the start. This one would not grow into a hurricane. Its winds topped out near 40 miles an hour, and it fell apart within a day of getting its name. By the numbers people usually use to size up a storm, Tropical Storm Arthur was small. If you find these reports steady and useful, you can subscribe to follow along. The surprise was the rain. Over central Louisiana, a gauge near the town of Cottonport caught more than 29 inches of water in a single day, and much of that fell in about 12 hours. If those totals hold, that is the most rain ever recorded in Louisiana in a 24-hour stretch, passing a mark that had stood since 1962. The Weather Service said early on that this was the kind of rainfall a place might see once in 1,000 years. This report walks through where Arthur came from, why so weak a storm carried so much water, where the worst of it fell, and what the region still has to watch as the water drains. Start with the part that does not fit. A tropical storm is supposed to announce itself with wind. It bends trees, tears at roofs, drives water up onto the shore. Tropical storm. Arthur did almost none of that. Its strongest winds reached only about 40 miles an hour, the speed of a stiff gust on a highway. It never became a hurricane, and it was never expected to. From the moment forecasters began watching it, they said the same thing in plain language. This storm would stay weak, and it would not last long. It held to that promise. Within a day of getting its name, Arthur fell apart over land and lost the shape of a storm. By the measures people usually reach for, wind speed and size and staying power, it was one of the smaller systems the season could produce. And yet a gauge in central Louisiana caught more than 29 inches of rain in a single day. Much of that water came down in about 12 hours. To picture it, imagine a bucket 2.5 feet deep filled to the brim, poured over every yard of ground across whole towns between sunrise and the same evening. If those totals hold up under review, that is the most rain ever recorded in the state of Louisiana in a 24-hour stretch. The record it passed had stood since 1962. This is the thing worth slowing down for. The danger here did not come from the storm being strong. It came from the storm being slow, wet, and parked in one place. A weak system can be the one that floods a region, and Arthur is a clear case of how that happens. Most of the people in the towns that took the worst of it had never seen this much water fall in a day. Their parents had not seen it either. The last time Louisiana came close was more than 60 years ago, and even that fell short of what Arthur delivered. So when the Weather Service reached for a way to describe it, they used a phrase that sounds dramatic but means something specific. They called it the kind of rainfall a place might expect once in 1,000 years. We will get to what that phrase really means, because it is easy to misread. For now, hold on to the simple shape of the story. A storm that the experts correctly called weak still managed to break a record that had stood for a lifetime and more. The place at the centre of this was Avoyelles Parish, a stretch of low, flat land in central Louisiana, where bayous wind through farm country. Towns there have names like Cottonport, Plocheville, Simmersport, and Mansoura. They sit only a little above the water that surrounds them, and their drainage was built for ordinary rain, not for this. When the gauge near Cottonport climbed past 29 inches, those towns had nowhere to send it. The numbers came in over June 18th and 19th, the day after Arthur got its name and the day after that. By then, the storm itself had already weakened into a loose swirl of moisture. That is part of what makes this event strange. The rain record was set not by the storm at its peak, but by its leftovers, sitting still and wringing themselves out over one corner of the map. 4 people are confirmed to have died as a result of Arthur and the weather around it. We will come to each of them plainly because they are part of the honest account. The damage so far is estimated at more than $100 million, a figure that will likely move as the water recedes and people return to their homes. What follows is the full story of this storm told in order. We start where Arthur started, far from Louisiana, as a ragged patch of weather near Mexico that no one had named yet. From there we follow it across the Gulf, watch it come ashore in Texas, and track the band of rain as it stalled over Louisiana and set its record. We will look at why a storm this weak could do this, what the flooding did to the towns in its path, and what the region still faces as the bayous slowly drop. The wind was never the point. The water was. That is the lesson Arthur leaves behind, and it is one that keeps repeating along this coast. To understand how it happened, we have to go back about a week before the rain, to a part of the world where two tired storms met. Arthur did not begin as Arthur. It began as Scraps. In the second week of June, a tropical wave was moving west across the warm waters near Central America. A tropical wave is a simple thing, a long ripple in the atmosphere that carries clusters of thunderstorms along with it. Dozens of them roll off the coast of Africa and across the tropics every summer. Most fade out. A few find the right conditions and grow into something with a name. This particular wave met a partner. Out in the eastern Pacific on the other side of Mexico, a storm called Christina had run its course and was breaking down. Storms do not always vanish cleanly. They leave behind a slug of moisture, a region of damp, unstable air that can drift for hundreds of miles after the storm itself is gone. The leftovers of Christina drifted east, crossed over the narrow land of Mexico, and met the incoming tropical wave near the Yucatan Peninsula. That meeting is where the story really starts. On June 12th, the combined system pushed into the Bay of Campeche, the deep notch of the Gulf of Mexico that curls in against Mexico's eastern coast. The water there is warm and shallow, the kind of surface that feeds rising air. The disturbance was disorganized, just a broad area of showers and thunderstorms with no clear middle, but it had moisture to spare and warm water beneath it. Forecasters at the National Hurricane Center began watching it right away. This is the patient, unglamorous part of their work. Long before a storm has a name or a track, they are studying satellite loops and buoy readings, asking a basic question. Is this mess starting to spin, or is it just rain? Most of the time the answer is just rain, and the system drifts apart. But they watch each one, because the cost of missing the one that organises is high. For Arthur's precursor, the early answer was uncertain. The thunderstorms came and went. The centre, if there even was one, kept wandering. A storm needs a clear core to strengthen, a single low point that the winds can wrap around. This disturbance did not have one. It was wide and loose, more a damp region than a storm. That looseness would stay with it almost to the end, and it is a big part of why Arthur never grew strong. It is worth pausing on the kind of system this was because it shapes everything that follows. A tight, well-formed hurricane is dangerous because of its winds and the wall of seawater it can push ashore. A broad, loose system like this one is a different animal. It does not concentrate its energy into a small, fierce eye. Instead, it spreads out, holds an enormous amount of water vapour, and rains across a wide area for a long time. The threat is not a single violent hour. It is the slow accumulation, inch after inch, over a day or more. So from its earliest days, this was a rain machine more than a wind machine. The ingredients were all about water, a tropical wave full of thunderstorms, the damp remains of a Pacific storm, a warm bay to lift the air and squeeze the moisture out of it. Put those together and you get heavy rain almost no matter what else happens. What the system lacked was organisation, and that shortfall kept it from becoming a hurricane. But here is the quiet truth that runs through this whole event. For the people who would eventually be flooded, the lack of organisation did not help them. A neater storm might have moved faster and carried its rain somewhere else. This sloppy one lingered. Its weakness was, in a strange way, part of what made the flooding so bad. By the middle of June, the disturbance was leaving the Bay of Campeche and turning toward the coast. It still had no name. On the forecasters' maps, it was just an area to watch, shaded to show the odds it would develop. Those odds were climbing, but slowly. The system was heading for land before it was heading for the open Gulf, which meant its next move would take it over Mexico. That is where it went next, and where it caused its first real trouble. Before it ever touched the United States, before it earned the name Arthur, this loose tangle of storms was about to drop heavy rain on a Mexican state that was not ready for it. The coast it aimed for first was Tamaulipas, the northeastern corner of Mexico that sits just south of Texas. On June 14th, the disturbance moved ashore there. It was still nameless, still loose, still more a flood of moisture than a true storm. But it carried the same heavy rain that would later define it, and Tamaulipas felt that rain first. The hardest hit place was Ciudad Victoria, the state capital, a city set inland against the foothills. According to the city's mayor, the rain damaged somewhere between 70 and 80% of the roads in the city. That is a striking figure. It means most of the streets people use to get to work, to school, to a hospital were torn up, washed out, or buried under runoff in a single bout of weather. Crews had to form teams just to clean the city afterward, clearing mud and debris from streets that had become channels for the water. Nearer the coast, in the port city of Tampico, the rain made an existing problem worse. The city had a sewage leak, and the heavy water worsened it, spreading contaminated water where people did not want it. This is one of the quieter dangers of a flood. The water itself is bad enough, but it also overwhelms the systems built to carry waste away, and the two mix. Floodwater in a city is rarely clean. These details matter for a reason beyond Mexico. They were an early reading on what this system could do. Before it had a name, before any American forecaster issued a warning to a Texas town, the disturbance had already shown its hand. It had taken a city's road network apart and fouled another city's water. The rain was the threat, and it had proven the point on its first landfall. After crossing into Mexico, the system did something that complicated the forecast. It moved inland and began interacting with a frontal boundary, a line in the atmosphere where two different air masses meet. Fronts are the engines behind a lot of ordinary weather, the cold fronts and warm fronts on a television map. When a tropical disturbance tangles with a front, the result is hard to predict. Sometimes the front tears the tropical system apart. Sometimes it adds lift and energy, helping the storms grow and organize. For this system, the meeting kept it alive and kept it raining, even as its shape stayed ragged. This is also the moment the storm's path bent. Instead of pushing deep into Mexico and dying over the mountains, the disturbance curved back toward the water and toward the United States. It tracked generally westward and then northward across the Gulf of Mexico, drawing close to the Texas coast. Every mile back over warm water was a mile it could gather more moisture. By now the calendar matters. This was happening in the run-up to June 16th and 17th, and the system was closing in on a long, low, flood-prone stretch of the American Gulf Coast. South Texas and Louisiana are flat. Their rivers move slowly. Their soil, in many places, was already wet from earlier storms that spring. A region like that does not need a powerful hurricane to flood. It needs a lot of rain in a short time, and that is exactly what was coming. Forecasters in the United States picked up the handoff from their counterparts watching Mexico. The disturbance that had chewed up the roads of Ciudad Victoria was now their problem, and it was strengthening, if slowly. The thunderstorms were becoming more widespread. The system was not yet a tropical storm, but it was organized enough that the Hurricane Center had to make a decision about how to warn people. The trouble was that the rules for naming and warning are built mostly around wind and structure. A system has to look a certain way and blow a certain speed before it earns the labels that trigger the loudest alarms. This disturbance did not yet look the part. It was wet and dangerous but shapeless. Forecasters needed a way to warn coastal Texas about a storm that had not quite become a storm. They had a tool for exactly that situation, a designation made for the in-between. Before we follow Arthur to its naming, it helps to understand the warm water it was crossing, because the heat in that water is what allowed a loose tangle of clouds to keep its strength all the way to the Texas shore. A tropical storm runs on warm water the way an engine runs on fuel. Take the heat away and the storm stalls. That is why hurricane forecasters watch sea surface temperature so closely, and why the Gulf of Mexico in June is such a productive place for storms. The water there had grown warm with the early summer, and as Arthur's precursor crossed it, the temperature underneath was running above 83 degrees Fahrenheit. That number deserves a moment. Storms generally need water of about 80 degrees, or warmer to form and hold together. 83 degrees is comfortably past that line. It is bathwater warm, the kind of sea that swimmers enjoy and that storms love for the same reason. Warm water at the surface heats the air just above it, and warm air rises. As that moist air climbs, it cools, and the water vapor in it condenses into clouds and rain. That process releases heat, which makes the air rise faster, which pulls in more warm, wet air from below. A storm is, at its heart, that loop running over and over. The warmer the water, the more vigorously the loop can run, and the more moisture the air can carry. This is the simple physics behind heavy tropical rain. Warmer air holds more water vapour. For every degree the air warms, it can hold a few percent more water. Over a sea running above 83 degrees, the air above it was loaded, a saturated sponge waiting to be wrung out. For Arthur, this warm water did two things at once, and they pulled in opposite directions. On one hand, the heat kept feeding the system, letting it survive its messy structure and its run-ins with land and fronts. A cooler sea might have let it die. On the other hand, the warm water did not let it become a hurricane, because other factors, which we will come to, were holding the storm's growth in check. So the heat sustained the rain without building the wind. That combination, plenty of moisture but little organisation, is a recipe for a flood rather than a wind disaster. It helps to separate the two threats a storm carries, because people often blur them together. Wind damage comes from a tight, strong storm, and tends to hit a smaller area hard and fast. Rain damage comes from moisture and time, and a weak storm can deliver it across a wide region over many hours. The same warm gulf that can spin up a fierce hurricane in one situation can, in another, simply load a weak system with water and send it ashore to rain itself out. Arthur was the second kind. There is a longer pattern worth naming here, calmly and without overstating it. The Gulf of Mexico has been running warm in recent years, warmer in many seasons than the long-term average. Warmer water means more available moisture, which means storms of all strengths can carry more rain than similar storms once did. This does not mean every storm will break a record. It means the ceiling on how much rain a storm can drop has been creeping upward. Arthur is one data point in that larger story, not the whole of it. For the coast that lay ahead, the practical meaning was straightforward. The water offshore was warm enough to keep the system fed all the way to landfall. The air it carried was thick with moisture, and the storm's loose, slow nature meant it would not race through and move that moisture along. Instead, it would idle near the coast and over land, releasing its water where it sat. By June 16th, the system was close enough to Texas that the hurricane center had to act. The disturbance was producing widespread thunderstorms, but it still lacked a well-defined center, the tight core that the rules require before a system can be called a tropical storm. Forecasters faced the same in-between problem as before. The danger was real and near, but the storm did not yet fit the official definition, so they used the designation built for that gap, the one that lets them post warnings for a system that is likely to become a tropical storm before it technically is one. That label, and what it told people along the Texas coast, is where the storm finally began to take on the name we now know it by. On the afternoon of June 16th, with the system sitting over southern Texas, the National Hurricane Center gave it a careful label. They called it a potential tropical cyclone. The phrase is a mouthful, but it solves a real problem. It lets forecasters issue watches and warnings for a system that has not yet organized into a true tropical storm, but is expected to soon, and that already threatens land. Without it, a coast could be left waiting for the paperwork to catch up while the rain moved in. The system earned that label at a specific moment, around the middle of the day on June 16th, while it was over southern Texas and still producing widespread thunderstorms without a clear center. That missing center was the only reason it was not simply called Tropical Storm Arthur right then. Everything else about it, the rain, the reach, the threat, was already in place. With the designation came the warnings, and those warnings carried their own vocabulary that is worth translating. Forecasters first issued tropical storm watches along a stretch of the Texas coast, from a place called Sargent up to Morgan City in Louisiana. A watch is the softer of the two alerts. It means tropical storm conditions are possible in the area, generally within about 2 days. It is a heads up, a signal to start paying attention and making plans, not a sign that the storm is upon you. As the system drew closer and its threat sharpened, the watch was upgraded to a tropical storm warning along part of that coast, between Sabine Pass and Morgan City. A warning is the firmer word. It means tropical storm conditions are expected, usually within about a day. The next day, the warning was stretched further down the coast to include Sargent. Watching the warnings spread along the map is a way of watching the forecasters grow more certain about where the storm would strike. These terms are not just bureaucratic, they are the main way the public learns how worried to be and how soon. A watch says prepare. A warning says act. For people who live along hurricane coasts, learning to hear the difference between those two words is part of staying safe. The watch is the time to fill the car with gas and move things off the floor. The warning is the time to finish those tasks and be ready to follow instructions. Alongside the wind warnings came a much broader alert about water, and this one reached far inland. Flood watches were issued for an enormous area, covering at least 16 million people, stretching from South Texas across to central Mississippi. As the system developed, those flood watches were pushed even further east into South Georgia. The size of that flood watch area was the real tell. The wind warnings hugged the coast, but the flood watches blanketed several states. That mismatch was the forecasters quietly pointing at where the danger truly lay. Governments moved in step with the forecasts. In Texas, Governor Greg Abbott issued a state of emergency for 101 counties, a wide swath of the state. He ordered the Texas Division of Emergency Management to ramp up to around-the-clock operations and to ready its resources. Across Texas, communities set up sandbag distribution points, giving residents the simple, time-tested means of keeping water out of their doorways for a while. Sandbags will not stop a true flood, but they buy time and turn back the shallow, creeping water that does much of a flood's early damage. There was an unusual wrinkle in all this preparation. The whole region was gearing up to host matches for the World Cup, the global soccer tournament, which the United States was helping stage that summer. In Houston, public festivals tied to the tournament were already being cancelled and shortened as the storm approached. We will return to that collision later, because it shows how a hazard ripples into events that have nothing to do with weather. For now, the picture along the coast was one of orderly readiness. The forecasts had been clear. The warnings had gone out in plain stages, watch then warning, with the flood watches drawn wide. People knew the rain was coming, even if the storm itself was still a loose, unnamed swirl. The naming was only hours away, and when it came, it would confirm what everyone already understood. The name arrived on June 17th. At 11 in the morning local time, the National Hurricane Center upgraded the system to a tropical storm and gave it the season's first name, Arthur. At that moment, it sat about 40 miles east-northeast of Port O'Connor, Texas, moving northeast at around 9 miles an hour, with sustained winds of 40 miles an hour. The upgrade did not come from a satellite picture alone. To call something a tropical storm, forecasters want proof of the winds, and they got it the way they often do, by flying into the storm. Aircraft known as hurricane hunters flew through the system, and buoys floating near it reported in as well. Both found winds at tropical storm force. With that evidence in hand, the Hurricane Center could make the upgrade official. The system that had been a potential tropical cyclone was now Tropical Storm Arthur. 40 miles an hour is the low end of the tropical storm scale, which begins at 39. Arthur was, in plain terms, a minimal tropical storm. It had crossed the threshold for a name, but not by much, and the forecasters were clear that it would not climb far above that line. They expected it to stay weak, and to weaken further once it moved back over land, dropping to a tropical depression and then falling apart. Why did it stay so weak, sitting as it was over that warm Gulf water that should have fed it? 3 reasons stand out, and together they explain the whole arc of the storm. The first was wind shear. Wind shear is a change in wind speed or direction with height, and it is the enemy of a tropical storm. A storm wants to stand up straight, like a spinning column reaching from the sea to the high atmosphere. Shear pushes the top of that column in one direction while the bottom stays put, tilting and tearing the structure. Arthur faced moderate shear, enough to keep knocking it off balance and prevent it from building a strong vertical core. The second was its loose center. A tropical storm strengthens by organizing around a single tight low. Arthur never managed that. Its center stayed ill-defined, a wandering, fuzzy thing rather than a sharp pivot. Without a firm core, the storm could not concentrate its energy, and the winds had nothing tight to wrap around. The third was time over water. A storm draws its strength from the warm sea, and Arthur spent only limited time over open water. It had crossed Mexico, tangled with land and a front, and approached the coast on a path that kept it near or over land much of the way. Each stretch over land cut it off from its fuel. There simply was not enough uninterrupted ocean time for it to build. Add those together, and you get a storm that was destined to stay small. Shear tore at its structure, its centre never firmed up, and it kept running out of the warm water it needed. The Hurricane Center read all of this correctly and told the public from the start not to expect a hurricane. Arthur held to that script almost exactly. After it was named on the morning of June 17th, it moved ashore and began to come apart. By that night, or early the next morning, it had weakened into a post-tropical cyclone, a system that has lost the tropical structure that defines a storm. Forecasters described it opening into a trough, which means it stopped being a closed swirl and stretched out into a mere kink in the wind pattern. As a named storm, Arthur was brief. It came and went in little more than a day. Here is the part that does not square with intuition. The storm peaked weak and then died fast, yet its heaviest rain, its record-setting rain, came after that. The leftovers did the damage, and to understand how a dying storm could break a 60-year rainfall record, we have to look closely at the one trait that made it so wet, the trait that mattered far more than its modest winds. The single most important thing about Arthur was not how strong it was how slow it was and how much water it held. Those two traits, slowness and moisture, are what turn a weak storm into a flood, and they deserve a clear explanation because they are the heart of this whole event. Start with the moisture. We have seen that Arthur formed from wet ingredients over very warm water, and that warm air holds more water vapour. By the time the storm and its remnants reached Louisiana, the air was nearly saturated, carrying close to as much water as it could hold. That is the supply side of the problem. There was simply an enormous amount of water in the sky, waiting for something to release it. Now at the slowness. A storm that moves quickly spreads its rain over a long track. It dumps an inch here, an inch there, and moves on, so no single place gets buried. A storm that moves slowly, or stops, does the opposite. It rains over the same ground hour after hour, and the totals at that one spot climb without limit. The speed of the storm, more than its strength, often decides how deep the water gets in any one town. Arthur's remnants were slow to the point of stalling. The system had lost its tight structure, which in a wind sense made it weak, but in a rain sense made it dangerous. With no firm steering and a loose shape, the leftover moisture simply sat over central Louisiana and rained. There was nothing to push it along. The same band of heavy storms kept forming over the same parishes, like a faucet left running over one square of the floor. Meteorologists have a word for this, training, and the image behind it is useful. Picture a line of railroad cars passing a single point. Car after car rolls over the same spot on the track, one behind another. A training line of thunderstorms does the same thing. New storms keep forming upwind and passing over the same towns, so those towns take hit after hit while places a few miles away stay dry. Training is how you get 29 inches in one location, and far less just down the road. This is the mechanism that broke the record. Not a powerful storm, but a weak, wet one that held still, while a training line of thunderstorms passed over the same ground for hours. The supply of moisture was nearly endless because the warm Gulf kept feeding it. The storm would not move, so the rain piled up in one place. Put those together and the numbers can climb past anything in the record books. It is worth sitting with how counterintuitive this is, because it shapes how people prepare. A strong hurricane gets respect. People board up windows and leave town. A weak tropical storm, or the remnants of one, can get waved off as just a rainy day. Yet the weak, slow, wet systems are responsible for some of the worst flood disasters this coast has ever seen. The strength of the wind is a poor guide to the danger of the water. There is a second factor that turned heavy rain into deep flooding, and it has to do with the ground rather than the sky. We will come to it in detail, but the short version is that the ground in central Louisiana was already wet. Weeks of earlier rain had saturated the soil. When ground is already full of water, new rain has nowhere to soak in. It runs off immediately, straight into the bayous and streets. So the same rainfall that might be absorbed by dry ground became, on saturated ground, instant flood. For now, hold on to the core idea. Arthur flooded Louisiana not in spite of being weak, but partly because of it. Its weakness came with slowness, and its slowness let the rain concentrate. Its disorganization came with a broad, wet structure that held water across a large area. The very things that kept it from becoming a hurricane were the things that made it such an efficient rain machine. The forecasters understood this clearly, and they said so. Days before the record fell, the leaders of the Hurricane Center were already telling the public that the wind was not the story. The story was water, and the warning they gave was unusually direct. The clearest voice in the days before the flood belonged to the National Hurricane Center, and its message was simple: forget the wind, watch the water. The center's director, Michael Brennan, said it plainly in a briefing. The main threat from Arthur, he explained, would be a prolonged, multi-day heavy rainfall event that could produce dangerous to life-threatening flash flooding. He went further, adding that the heavy rain threat would persist even after the centre of Arthur moved inland and fell apart. That last point was the crucial one, and it proved exactly right. Brennan was telling people not to relax when the storm weakened. The danger was not tied to the storm staying a storm. The rain would outlive the system that brought it. In a briefing, with a map behind him showing flood watches from the Texas coast to South Georgia, he was pointing at the real hazard while the storm itself was already fading. The forecast put numbers to the warning. The Hurricane Center said Arthur was expected to produce rainfall totals of 5 to 10 inches across a large part of the Gulf Coast, with isolated higher amounts near 20 inches through the end of that week. 5 to 10 inches of rain is a serious soaking on its own, the kind that floods low spots and closes roads. The isolated 20-inch figure was the alarming part, a quiet acknowledgement that somewhere in that wide area, the training storms could dump far more than the average. It is worth noting how that forecast held up. The general totals landed in the predicted range across much of the region, but the isolated maximum blew past even the 20-inch figure, reaching 29 inches and beyond in central Louisiana. Forecasting the peak of a training rainfall event is one of the hardest things in weather, because it depends on exactly where the band sets up and how long it holds. The forecasters got the shape of the threat right. The precise location and height of the peak is something only the storm itself decides. The flood watches drawn around the warning covered a remarkable number of people. At least 16 million were under flood watches from South Texas to central Mississippi, and that area later grew eastward into South Georgia. A flood watch means conditions are right for flooding, and people should be ready. It is the rain equivalent of a tropical storm watch, a signal to prepare. When 16 million people are under one, the forecasters are saying the threat is not a local problem but a regional one. On the ground, communities translated the warning into action. In Louisiana, parishes handed out sandbags. In and around New Orleans, where flooding is an old and constant worry, officials cleared pumping stations and drainage systems ahead of the rain, and brought in extra pumping equipment to cover stations that were offline. Residents in part of the New Orleans area were asked to stay away from bodies of water. These are the unglamorous steps that decide how a flood plays out, taken quietly in the day or two before the rain. There were human moments in the preparation. At a sandbag collection point in Covington, Louisiana, a resident named Luke Barwick filled a few bags after his house had already taken on a lot of rain the day before. He and a neighbour decided it was simply a good idea to grab a few bags just in case. That small, sensible act is what preparation looks like at the level of a single household. Not panic, just a reasonable response to a clear warning. The warning was about as good as a warning gets. It was early. It was specific about the threat being rain rather than wind. It came with numbers and a wide net of watches, and it correctly told people that the danger would outlast the storm. The forecasters did their job. What they could not do was move the rain or choose where it fell hardest. That was up to the storm, and the storm's first act on American soil was in Texas, where the water arrived before Louisiana ever saw the worst of it. Texas felt Arthur first. The storm came ashore near Galveston, the low barrier island that guards the approach to Houston, and the rains spread along the upper Texas coast. Even as a weak and fading system, Arthur had plenty of water to give, and Texas was the first to receive it. Some of the heaviest Texas rain fell in Brazoria County, southwest of Houston, in the towns of Freeport and Clute. Parts of that area took in more than 8 inches. That is a heavy rain by any measure, enough to flood streets and stall cars. 2 people had to be rescued from a vehicle that became stranded in rising floodwater in Freeport. That scene, a car caught in water that rose faster than the driver expected, would repeat across the region in the days to come. It is one of the most common and most preventable dangers in a flood. The worst of the flooding in Brazoria County was avoided, though, and the reason is instructive. Before the storm, officials had lowered the water levels in the local drainage systems. By emptying the canals and channels ahead of time, they made room for the rain to go somewhere. When the water came, the system had capacity to absorb it. This is a quiet kind of heroism, the work of engineers and operators who drained the ditches before anyone outside their offices was paying attention. It did not stop all the flooding, but it kept it from being far worse. Houston itself, the great sprawling city that has flooded so badly in past storms, was largely spared the heaviest rain. The worst bands set up to the side of the city rather than over it. Houston still received several inches, and that was enough to close portions of Interstate 10 near the city, one of the main arteries of the region. But the catastrophe that Houston has known in other storms did not arrive this time. The rain went elsewhere. Upstream of Houston, water managers made a hard but routine decision. Because of the rain from Arthur and from earlier storms, the San Jacinto River Authority released water from Lake Conroe, a reservoir north of the city. Releasing water from a reservoir during heavy rain sounds backward, but it follows a clear logic. A reservoir can only hold so much. If it fills past its limit, it can fail or overflow uncontrollably, which is far worse than a managed release. So operators let water out in a controlled way to keep room behind the dam. It is a balancing act, weighing the flooding caused downstream by the release against the greater danger of a reservoir pushed past its capacity. Further inland, in central Texas, the precursor to Arthur had already been causing trouble before the storm even had a name. Flash flooding struck across the region. In and around Waco, the situation grew serious. Flooding stalled vehicles on Interstate 35 near Robinson and on roads in the nearby town of Hewitt. An RV park had to be evacuated because of rising water. Emergency responders rescued a person who had climbed a tree to escape the floodwaters near a local high school. In all, at least 20 people were rescued from floodwaters in the Waco area. A county road in Milam County was washed out entirely, and in Austin, more than 100 low-water crossings were closed, along with a popular swimming spot called Barton Springs Pool. There is a shadow over central Texas that makes these scenes especially tense. Just about a year earlier, along the Guadalupe River, a flash flood disaster had taken more than 130 lives on the 4th of July, including dozens of children at summer camps. That tragedy is recent and raw. The hill country's steep terrain and hard soil make it dangerously prone to flash flooding, where water rises in minutes rather than hours. When heavy rain returns to that region, people remember, and the memory sharpens every warning. In this case, central Texas was spared a repeat. The rescues near Waco ended without the loss of life that the Guadalupe had seen. The flooding was serious, the roads were dangerous, but the worst did not come to pass there. The water did its damage and receded. Texas in the end took a hard hit, but not the historic one. The heaviest rain, the record-breaking rain, was still ahead, and it was setting up just to the east. As Arthur's remnants drifted into Louisiana and slowed almost to a stop, a band of storms began to form over one rural parish, and it showed no sign of moving. The place where everything came together was Avoyelles Parish, a stretch of central Louisiana, where the land lies flat and low, and the bayous wander through farm country. As Arthur's remnants crossed into the state and lost the last of their structure, a band of heavy thunderstorms set up over the southeastern part of the parish, and then it stopped moving. A National Weather Service meteorologist based in Lake Charles, Andy Tingler, described what happened in the simplest possible terms. That band, he said, just kind of stayed there. That is the whole disaster in one sentence. The rain did not sweep through. It parked. It found a spot over Avoyelles and rained on it for hours, while the towns underneath had no way to shed the water fast enough. The downpour began early on a Thursday morning. From roughly 4 in the morning until around 3 or 4 in the afternoon, the system dumped between 20 and 30 inches of rain in some areas, mostly over the town of Cottonport and the village of Ploucheville in the southern part of the parish. Catch the timing in that. 20 to 30 inches in about 12 hours in daylight, much of it before lunch. Residents were caught off guard because the storm that brought it was supposed to be over. This is the training process we discussed earlier, seen in real life. New thunderstorms kept forming and passing over the same towns, one after another, like cars over a single point on a track. Each one wrung out more of the saturated tropical air. Because the larger system had stalled, there was nothing to push the band along, so the same parishes took the full force again and again, while neighbours a short drive away stayed comparatively dry. The geography of Avoyelles made everything worse. These are delta communities, low-lying towns set in flat, swampy ground near the Atchafalaya River. Places like Simmersport, Cottonport, Plocheville, Moreauville, and the area around Lettsworth sit only a little above the water that surrounds them. Their drainage runs mostly through bayous, slow natural channels rather than fast-engineered canals. A bayou drains gently in ordinary times. Faced with 30 inches of rain in half a day, it simply fills and spreads. There was another problem that the storm did not create but badly exposed. The ground was already saturated. Central Louisiana had taken weeks of rain before Arthur, and the soil was full. When ground is already holding all the water it can, new rain cannot soak in. It runs off at once. So the rain that fell on Avoyelles did not sink into fields and yards. It poured straight into the bayous and streets, which were already brimming, and the water rose fast. Put those pieces together, and you have the recipe for a flash flood emergency. A nearly endless supply of tropical moisture overhead. A stalled storm that would not move the rain along. A training band hammering the same towns for 12 hours. Flat, low ground drained only by slow bayous, and soil so saturated that every drop became runoff. Any one of these would cause trouble. All 5 at once produced something the parish had never seen. The water came up with frightening speed. In low-lying delta communities that were already saturated, the bayou-based drainage systems were quickly overwhelmed. Streets became channels, yards became ponds, homes that had stayed dry through past storms took on water, and because so much of this happened in a single morning, people had little time to react. A flood that builds over days gives warning. A flash flood that rises in hours does not. By the time the rain eased, the gauges in Avoyelles Parish were showing numbers that stopped the meteorologists in their tracks. The figure near Cottonport was not just high, it was, on its face, higher than anything in the state's record books. Before anyone could quite believe it, the question shifted from how much rain was falling to whether what had just happened was the most rain Louisiana had ever recorded in a single day. That number, and what it meant, is where we turn next. The number that came out of Avoyelles Parish was 29 6/100ths of an inch. A rain gauge located between the town of Cottonport and the village of Plocheville recorded 29.06 inches of rain. Some measurements nearby ran even higher, with one reading reported at over 31 inches. The figures came in over June 18th and 19th, and the striking part was how fast the water fell. Much of that total, according to the National Weather Service, came down in just 12 hours. It is hard to picture 29 inches of rain, so it helps to translate it. Stand a yardstick on the ground. Now imagine water rising almost to the 29-inch mark, more than 2/3 of the way up. That is how much fell from the sky onto flat ground that could not drain it. Spread that across whole towns, and the result is not puddles. It is a landscape turned to water, with homes and roads and fields submerged. The gauge that caught the peak sat in a meaningful spot between 2 of the hardest-hit communities, Cottonport and Plocheville. A hydrologist with the Weather Service office in Lake Charles, Jonathan Brazel, confirmed the reading and explained where it came from. 20 to 30 inches of rain fell across Avoyelles that Thursday, he said, mainly over those 2 southern communities, between about 4 in the morning and 4 in the afternoon. The official total at that one gauge was 29.06 inches. A second voice from the Weather Service, Scott Kleebauer of the Weather Prediction Center, confirmed the same figure independently. More than 29 inches of rain was reported in Cottonport on June 18th and 19th, he said, much of it within just 12 hours. When 2 separate arms of the Weather Service cite the same number, it is a sign the reading is solid, even if the official record still has to go through review. That review matters, and the forecasters were careful to flag it. A number like this does not become an official state record the moment a gauge shows it. It has to be checked. Weather Service staff, along with the state climatologist Jay Grimes, planned to travel to Avoyelles Parish to inspect every rain gauge in the affected areas. They would confirm the equipment was working correctly, rule out errors, and verify that the reading was real. Until that work is done, the totals are best described as preliminary. They are almost certainly close to right, but the official stamp comes after the checking. This is worth dwelling on, because it shows how careful science treats an extraordinary claim. The instinct, faced with a stunning number, is to announce it at once. The Weather Service did the opposite. They reported the reading, they said plainly what it would mean if confirmed, and then they went to the field to check it gauge by gauge. That patience is not a weakness in the story. It is the reason the eventual number can be trusted. What the gauge measured, though, was only half of what made the day so dangerous. A number on an instrument is abstract. The water on the ground was not. The same 29 inches that registered on the gauge fell on towns that had nowhere to put it, and the result was the flash flood emergency we have been circling. The gauge and the flood are two ways of seeing the same event, one in numbers and one in submerged streets. There is a particular danger in rain that falls this fast. 29 inches spread over a week would still be a great deal of water, but the land could shed much of it as it came. 29 inches in 12 hours overwhelms everything at once. There is no time for bayous to carry it away, no time for the ground to absorb it, no time for people to move. The speed is what turns a remarkable rainfall total into a life-threatening flood. And so the question that hung over Avoyelles Parish was not only how much rain had fallen, but whether anyone had ever recorded this much in Louisiana before. The early answer from the people who keep these records was no. To understand what that means, we have to look at the record that Arthur appears to have broken, a mark that had stood since long before most people in those flooded towns were born. Before Arthur, the most rain ever recorded in Louisiana in a 24-hour period was about 22 inches. That record was set in 1962 by a tropical depression, the weakest class of tropical system, even lower on the scale than a tropical storm. It is a fitting piece of history that the old record was also set by a weak system rather than a mighty hurricane. The lesson that weak storms bring the worst rain is not new. It is written into the record book itself. 22 inches stood as the mark for more than 60 years. Generations of Louisiana storms came and went without beating it. Hurricanes far stronger than Arthur struck the state in those decades, with winds that flattened buildings and surge that swallowed the coast, and none of them dropped as much rain in a day as that 1962 depression. The record was not soft. It had survived a long time and a lot of weather. Arthur's remnants appear to have broken it by a wide margin. 29 inches against a record of 22 is not a narrow win. It is roughly 7 inches more, an increase of nearly a third over a mark that had held for over 60 years. Records in weather usually fall by small amounts, an inch here, a fraction there. A jump of 7 inches past a long-standing record is the kind of leap that makes meteorologists look twice, which is part of why they went to check the gauges so carefully. It helps to understand what a state 24-hour rainfall record actually is. It is the single greatest amount of rain measured at any one official location in the state within a 24-hour window, across all of recorded history for that state. It is not an average or a regional total. It is the peak, the most any one place has ever caught in a day, anywhere in Louisiana as far back as the records go. To break it, a single gauge has to measure more rain in a day than any gauge in the state ever has. That is what the instrument near Cottonport appears to have done. There is a reason this kind of record carries weight beyond the meteorologists who track it. For the people who live in a place, a state rainfall record is a marker of the outer edge of what their home has known. Most residents of Avoyelles Parish had never seen this much water fall in a day, and neither had their parents or grandparents, because the previous ceiling was set before many of them were born. When forecasters say this may be the most rain Louisiana has ever recorded in a day, they are saying it sits at the very limit of the state's experience. We should be honest about the word preliminary, because it still applies. As of the verification work, the record-breaking total was reported but not yet formally certified. The gauges were being checked. The state climatologist was involved. It is possible, though it appears unlikely given how two separate offices confirmed the reading, that the final certified number could shift. The honest way to say it is this: Arthur's reign almost certainly broke the state record, and the official confirmation was still being completed. That careful language does not shrink the event. Even before any stamp of certification, the basic facts were clear and confirmed. An extraordinary amount of rain fell on central Louisiana in about 12 hours. It exceeded the previous state record by a wide margin. The towns beneath it flooded with a speed and depth they had never experienced. The certification process would put a final number on the record, but it would not change what the people of Avoyelles had already lived through. There is one more phrase the Weather Service used that needs careful handling, because it is easy to misunderstand and easy to sensationalise. They said this was likely a 1-in-1,000-year rainfall event. That sounds like a claim that such rain comes only once every 10 centuries, which is not quite what it means. The real meaning is more precise and, in its way, more sobering, and it is where we turn as the story moves from the rain to its consequences. The phrase, a 1-in-1,000-year rainfall event, sounds like a calendar promise. It seems to say that this much rain falls only once every 1,000 years, so no one need worry about it again for a very long time. That reading is wrong, and getting it right matters, because the wrong reading can lull people into a false sense of safety. What the phrase actually describes is a probability. A 1-in-1,000-year rainfall has, in any given year, about a 1/10 chance of happening at a given place. The hydrologist Jonathan Brazel put it in those terms. Such an event, he said, has about a 0.1% chance of occurring in any single year. That is a small chance, but it is a chance that resets every year. The dice are rolled again each season. The 1,000-year label is a way of ranking rarity, not scheduling it. It tells you that rain this heavy is extremely unusual for this location, the kind of thing that sits at the far edge of what is statistically possible. It does not tell you that the clock now resets and the region is safe for 10 centuries. In principle, a place could see 2 such events in consecutive years. It would be staggeringly unlucky, but the math allows it, because each year's small chance is independent of the last. There is a reason these labels can mislead, and it is worth naming plainly. The numbers behind them come from the historical record, from decades of rainfall data used to estimate how often extreme totals occur. If the climate is shifting, and heavy rain is becoming more common, then the old estimates may understate the true odds. An event the records call 1-in-1,000 years might, under current conditions, be happening more often than that. So the label can make rare rainfall sound rarer than it now is. For Arthur, the Weather Service was careful with the term. Brazel said the Avoyelles downpour would probably fall into the 1,000-year category, and a Lafayette-based meteorologist, Rob Perillo, noted that the numbers pointed to a potential 1,000-year event that could break the state record. The words probably and potential are doing real work in those sentences. The forecasters were signalling extreme rarity, while leaving room for the verification still to come. The practical meaning of all this is simpler than the statistics. This was rain at the outer limit of what central Louisiana has ever experienced or expects to experience. Whether the final label is 1-in-500 years or 1-in-1,000 years, the message is the same. The towns of Avoyelles Parish were hit by something that sits at the very edge of possibility, an event so rare that the systems built to handle ordinary floods were never designed for it. That is the honest frame. Not that this will never happen again, because it could, even soon. Not that the region is now safe, because it is not. Just that this particular rainfall was about as rare as rainfall gets, and that the bayous and drainage and roads of central Louisiana met a force far beyond what they were ever meant to hold. It also reframes how we should think about the damage. When a 1,000-year rain falls, the flooding that follows is not a sign that anyone failed. The drainage systems did not break because they were poorly built. They were overwhelmed because they faced a load no reasonable system is built to carry. There is a difference between a system that fails under ordinary stress and one that is simply swamped by the extraordinary. Avoyelles faced the extraordinary. Governor Jeff Landry of Louisiana captured the plain truth of it at a press conference in the town of Mansoura. The amount of rainfall, he said, was simply historic. That word, historic, is the right one. It does not exaggerate. It places the event where it belongs, in the record books, at the top of the list of what the state has known. So we should hold the 1,000-year phrase the way the forecasters did, as a measure of rarity rather than a promise about the future. It tells us this was a once-in-many-lifetimes rain. It does not tell us we are safe now, and it does not by itself explain why so much water turned so quickly into so deep a flood. For that we have to leave the sky and look at the ground, at the saturated soil and slow bayous that decided how the rain became a flood. Rain is not flooding. The two are connected, but the path from one to the other runs through the ground, and in central Louisiana that ground was already failing before Arthur's first drop fell. Understanding why takes us from the storm overhead to the soil and water beneath, where the real disaster was decided. Begin with the soil. Ground absorbs rain the way a sponge absorbs water, up to a point. Dry soil has room. It takes in the rain, holds it, and slows the runoff, giving streams and drains time to carry the water away. But a sponge that is already full cannot take any more. Pour water onto saturated ground and it does not sink in. It runs off immediately, every drop heading straight for the lowest point. Central Louisiana came into this storm with full sponges. The region had taken weeks of rain before Arthur, soaking the soil to capacity. The low-lying delta communities of Avoyelles Parish were already saturated from that earlier weather, so when 29 inches fell in 12 hours, almost none of it could soak in. The ground was closed for business. Nearly all of that rain became instant runoff, racing across the surface toward the bayous. Now consider where that runoff had to go. In much of Avoyelles, drainage runs through bayous, the slow, winding natural waterways that thread through the delta. A bayou is built by nature for gentle work. It carries the steady, ordinary flow of a flat, wet landscape, moving water along at an unhurried pace. It is not a storm drain. It cannot rush a sudden flood out to the river in a hurry. When a bayou-based drainage system meets a flash flood, it fills, then spreads beyond its banks because it has no fast way to pass the water through. The land itself offered no help. Avoyelles is flat. Floodwater drains by gravity, pulled downhill toward lower ground, and on flat land there is little downhill to pull it. Water that falls on a steep slope runs off fast. Water that falls on a flat plain sits and spreads. The delta's flatness, which makes it good farm country, made it terrible at shedding a sudden deluge. There was one more cruel detail. Many of these communities sit above sea level, which would normally help them drain. Yet despite that elevation, they flooded badly, because the problem was never about being below the sea. It was about the speed and volume of the rain against the slowness of the bayous and the fullness of the soil. Elevation protects against a rising sea or river. It does almost nothing against rain that falls faster than the land can carry it away. Stack these factors and the flood becomes inevitable. Saturated soil that turned all the rain to runoff. Slow bayous that could not pass the runoff through. Flat land that gave the water nowhere to drain. The result was that the rain, instead of soaking in or flowing away, simply piled up on the surface, rising through yards and streets and into homes. This is why two places can get the same rain and suffer very differently. A town on a hillside with deep, dry soil and a fast-moving creek might shrug off 10 inches. A flat delta town with full soil and a sluggish bayou can be devastated by the same amount. The rain is only the input. The ground decides what the rain becomes. It also explains the timing of the disaster. Because the soil was already full, the flooding did not wait for the rain to accumulate over days. It began almost as soon as the heavy rain started, because every drop was running off from the first minute. People who expected a flood to build slowly, giving them time to prepare, instead found water rising within hours. The saturated ground turned a heavy rain into a fast flood. The forecasters had understood this risk. It is part of why the flood watches went out so early and so wide. They knew the ground across the region was primed, that the soil had little left to give, and that any heavy rain would run off fast. The warning about life-threatening flash flooding was not just about the amount of rain. It was about the rain meeting ground that could not absorb it. So the flood that swept through Avoyelles Parish was the product of sky and earth together. The sky delivered a record rain. The earth, already full, sent nearly all of it rushing into towns that sat low and flat and drained slow. The two combined to put whole communities under water, and it is to those communities that we now turn. The flood reached the towns by name, and each one tells part of the story. In Avoyelles Parish, the communities of Simmersport, Plocheville, Cottonport, Moreauville, and Mansoura took the brunt of it, along with the area around Lettsworth in northern Point Coupé Parish nearby. These are small places, the kind where people know their neighbours, and the water came into them all at once. In Simmersport, streets throughout the town went entirely underwater. Yards were inundated as the neighbourhood drainage stood completely overwhelmed by the sheer volume of water. Residents found themselves stranded. The roads they would normally use to leave turned into channels. Photographs from the town showed people wading through high water, families sitting on front porches surrounded by flood, and a church graveyard partly submerged. In one image, a trio of goats stood on a porch, keeping to the one dry spot they could find. In Mansoura, the Louisiana Department of Transportation shut down a state highway that had become impassable, swallowed by deep, fast-moving floodwater. Cutting a major road is a serious step, taken only when driving it becomes deadly. Fast-moving water over a road is among the most dangerous things in a flood, because it can sweep a car away in water that looks shallow. Closing the highway was a way of keeping people from a risk they might not see until it was too late. In Cottonport, near the gauge that caught the record rain, emergency dispatchers confirmed a high-water rescue, crews working to save people trapped by water that was rising fast around them. The Weather Service had issued a rare flash flood emergency for Avoyelles Parish, the most urgent category of flood alert, reserved for situations where lives are in immediate danger. It is not a phrase forecasters use lightly. When they reach for it, they are saying the flooding is not just damaging property but threatening to kill. The rescues stretched across the parish and beyond. Crews from the Avoyelles Parish Sheriff's Office worked alongside teams from neighbouring parishes, local fire and police departments, the National Guard, and the Louisiana Department of Wildlife and Fisheries. They kept at it for more than a full day after the storm, even as the heat index climbed into the triple digits, turning the flooded landscape into a hot, exhausting place to work. The rescuers pulled people from homes and stranded vehicles, and they evacuated the remaining patients from a nursing home to safety. Amid the rescues, there was one hard local decision that shows how complicated a flood can be. In Cottonport, as a bayou called Bayou Rouge began to overflow at the height of the storm, the town's mayor ordered a cut in a ramp that separated it from another bayou, Bayou du Lac. The idea was to relieve the pressure of the rising water on the town, but moving water in a flood means moving the problem. Some officials say the cut worsened the flooding downstream, in the communities of Plocheville and Dupont. There was no clean choice. Relieving one town's flooding sent water toward another. That is the brutal arithmetic of a flood, where the water saved from one place has to go somewhere, and somewhere is usually downhill toward a neighbour. For all the destruction, there is a number from Avoyelles worth holding on to. In the parish at the centre of the record rain, where homes and roads went under, and roughly 100 residents were displaced, no deaths and no injuries were reported there. A parish official surveying the damage said as much. Backwater flooding had worsened conditions in some areas, and the water was still climbing in places, but the people had gotten out. The rescues had worked. That outcome was not luck alone. It was the product of the early warnings, the wide flood watches, the rare flash flood emergency that told people the danger was real, and the rescue crews who moved fast. The water took homes and possessions and a way of life, at least for a time. A resident summed up the feeling simply, saying they would just have to start over. But in the parish that took the worst of the rain, the people came through. The Red Cross opened an emergency shelter at a community centre in Mansoura for those who had lost their homes. Food was handed out in front of city halls. The slow, patient work of recovery began even as the water still stood. And while Avoyelles was the heart of the flood, the water did not stop at the parish line. It pushed against rivers and dams across the region, and in places those defences came under threat. Sea, water that cannot drain into the ground, or the bayous pushes instead against the rivers, and the rivers pushed back into the land. Across the flooded region, waterways that normally stayed within their banks rose and spread, and the structures built to hold water in check came under strain. The most serious of these threats involved a river overflowing in Louisiana and a dam in danger in Mississippi. In Louisiana, the Chafuncti River overflowed. As it rose past its banks, the water reached the buildings around it, flooding structures in the area of St. Tammany Parish that the river runs through. A river overflowing is different from rain pooling in streets. It is a sustained flood, fed by all the runoff pouring in from upstream, and it tends to last longer because the river keeps delivering water long after the rain has stopped. Buildings near an overflowing river can stay flooded for days as the swollen river slowly falls. The more frightening situation was in Mississippi, at a place called Anchor Lake. A dam there began to present a threat of failing. A dam failure is among the most dangerous things that can happen in a flood, because it releases a held-back body of water all at once, sending a sudden wall of water downstream with little warning. The lake behind a dam represents an enormous amount of stored water, and a dam under strain is a danger to everyone below it. Officials responded the way responders must when a dam is at risk. They evacuated the homes most directly in the path, clearing about 30 homes near the dam. Then they took the harder step of draining the lake to reduce the strain on the dam systems. Lowering the water behind a dam reduces the pressure pushing against it, easing the risk of failure. It is the same logic as the reservoir release in Texas, taken under more urgent circumstances. Better to let the water down in a controlled way than to risk the dam giving way and releasing it all at once. These dam and river dangers reveal a second layer of the flood, beyond the rain falling on towns. The first layer is direct, the rain landing on a community and pooling in its streets. The second is indirect, the runoff gathering in rivers and behind dams, threatening places that may be miles from where the heaviest rain fell. A town downstream of a strained dam might see little rain itself, yet face real danger from water that fell far away and is now pressing against the structure above it. The roads told the same story of water on the move. In Mississippi, an interstate highway, Interstate 59, was left submerged under more than a foot of water by the rain from Arthur's precursor. Many other major roads were closed across Pearl River and Hancock counties as the water rose. A submerged interstate is more than an inconvenience. It cuts the routes that emergency vehicles and supplies travel, isolating communities and slowing the response when help is most needed. This is the broad reach of a flood that the rain totals alone do not capture. The 29 inches fell on Avoyelles, but the consequences spread outward through the water system. Rivers carried the flood far from where the rain landed. Dams in distant counties came under threat. Highways went under in states away from the worst of the downpour. The water did not respect the boundaries of the heaviest rain. It flowed wherever gravity took it, carrying the flood across a wide region. Through all of this, the responders did the patient, unglamorous work of managing water. They drained a lake to save a dam. They closed roads, turned to rivers. They watched the swollen Chafuncte and the rising bayous, tracking where the water would go next. Much of flood response is not dramatic rescue. It is this quiet management, the moving and holding and releasing of water to keep the worst from happening. And while the rivers rose and the dam strained, the same storm system was producing a different kind of danger overhead. The tropical air that brought the rain was also spinning up tornadoes, and they came down across the same flooded region, adding wind to water in the most hard-hit areas. A tropical storm does not only bring rain and wind in a steady sweep, it can also spin off tornadoes, sudden and violent and brief, and Arthur did. The National Weather Service confirmed at least 9 tornadoes spawned by the storm across southeastern Louisiana and Mississippi. As the agency surveyed the damage, it found more than it first counted, confirming additional tornadoes in the towns of Houma and Slidell in Louisiana. It can seem strange that a weak, soggy tropical system would produce tornadoes at all. The storm's winds were modest, only around 40 miles an hour at their peak. But tornadoes in a tropical system do not come from the storm's overall wind speed. They come from the way the storm's structure can twist the air in small local pockets, and that process does not need a powerful storm to work. Here is the mechanism in plain terms. A tropical system carries bands of thunderstorms that wrap around its center. Within those bands, the wind changes speed and direction with height, the same wind shear that weakened Arthur overall. On the large scale, shear tears a tropical storm apart. But on the small scale, inside a single thunderstorm, that same change of wind with height can set the air rotating. A thunderstorm sitting in the right wind environment can tilt that rotation upright and concentrate it, and a tornado can drop from the cloud. This is why the outer bands of tropical systems are known for tornadoes, often well away from the storm's center. The tornadoes that Arthur produced came in the bands of storms spreading across Louisiana and Mississippi, not from the failing core of the system itself. A place could be far from the storm's middle and still face a tornado, because the bands reached out across hundreds of miles. Tropical tornadoes tend to be smaller and shorter-lived than the great tornadoes of the open plains, but they are dangerous in their own way, precisely because they come with little warning. They form fast, often at night or amid heavy rain that hides them from view. A person watching for floodwater might not be watching the sky, and a tornado wrapped in rain can arrive almost unseen. The warning times are short, sometimes only minutes. The combination of threats is what made Arthur's tornadoes especially tricky. People in the affected areas were already dealing with flooding, already focused on rising water and blocked roads. Adding a tornado threat on top of that splits attention and complicates the response. The safety advice for a flood and the safety advice for a tornado can even conflict. In a flood, you may need to move to higher ground or a higher floor. In a tornado, you want to get low to the lowest floor in an interior room. Facing both at once forces hard, fast choices. The standard guidance in a tornado holds even in a tropical system. When a tornado warning is issued, the safest place is a small interior room on the lowest floor of a sturdy building, away from windows. A hallway, a closet, or a bathroom near the centre of the structure offers the most protection. The goal is to put as many walls as possible between yourself and the outside. These are the same steps that save lives in any tornado, and they apply just as much to the brief, rain-hidden tornadoes of a tropical storm. The 9 confirmed tornadoes added to the toll of an already punishing storm. They damaged buildings and added to the danger in towns that were busy fighting floodwater. In the Midwest, separate from the tropical tornadoes, the broader weather pattern tied to the storm produced numerous reports of tornado and wind damage as well, though that region saw no immediate reports of deaths or life-threatening injuries from it. So Arthur was never only a rainstorm. It carried tornadoes in its bands, threats that arrived fast and demanded a different response than the flood. The same tropical air that wrung out a record rain over Louisiana also twisted itself into funnels over the same ground, and that ground stretched east into Mississippi and Alabama, where the storm wrote yet another chapter of damage. East of Louisiana, the storm kept raining, and Mississippi and Alabama took their own heavy share. The rain totals there did not reach the record figures of Avoyelles Parish, but they were severe, and they came with their own losses. In Mississippi, the community of Perkinston received about a foot of rain, 12 inches or more, and a place called Black Creek measured a similar amount. A foot of rain is a major flood event in most places. That it ranks as a secondary story in the account of Arthur shows just how extreme the Louisiana totals were. 12 inches of rain in Mississippi caused real flooding, closed roads, and forced rescues, and yet it was less than half of what fell on Cottonport. The storm spread heavy rain across several states, with the worst concentrated in that one Louisiana parish. Mississippi suffered the storm's most clearly attributed death. A road worker died while working on cleanup efforts after Arthur in Franklin County. This is a particular kind of tragedy, one that comes not during the storm but after it, during the dangerous work of recovery. Cleanup after a flood is hazardous. There is unstable ground, damaged equipment, fast water still moving through swollen channels, and exhausted workers labouring in difficult conditions. The road worker's death is a reminder that a storm's danger does not end when the rain stops. Mississippi also faced the dam threat at Anchor Lake we discussed earlier, with about 30 homes evacuated and the lake drained to ease the strain, and it dealt with widespread flooding of its roads. The submerged stretch of Interstate 59 and the many closures in Pearl River and Hancock counties cut through the state's transportation network. Across the affected area, around 38 people were rescued from floodwaters, pulled from homes and vehicles caught in the rising water. The state's governor, Tate Reeves, declared a state of emergency for the impacted areas. A state of emergency is a legal and practical step that unlocks resources, allowing a state to direct money, equipment, and personnel to the crisis and to request federal help. By the time Arthur's reign reached Mississippi, the governors of 3 states, Texas, Louisiana, and Mississippi, had each declared emergencies, a measure of how broadly the storm's effects spread. In Alabama, the rain brought flooding and power outages. A state route, Alabama State Route 198, was partially closed because of flash flooding. More than 20,000 customers lost power in the state, most of them in Mobile County along the coast. Losing power during and after a storm compounds every other hardship. It silences air conditioning in dangerous heat, spoils food, and cuts the lights and the means to charge a phone and stay informed. With the heat index climbing into the triple digits in the storm's wake, the loss of air conditioning was not a minor discomfort, but a genuine health risk for the vulnerable. The power losses extended beyond Alabama. In Florida's Escambia County, around 100 customers lost power, a smaller number reflecting the storm's weaker reach there. In Georgia, more than 4,800 people lost power, and in North Carolina, more than 2,000 customers in Brunswick County lost power, even though that state saw little direct impact from the system itself, mostly catching some lingering moisture. Far to the north, in the Midwest states of Illinois, Indiana, Kentucky, and Ohio, more than 130,000 homes and businesses lost power from the broader storm pattern associated with Arthur, a reminder that a single weather system can reach across half a country. Alabama also took sensible precautions along its coast. Double red flags flew on the beaches in Baldwin County, the signal that the water is closed to the public because conditions are too dangerous to enter. Mobile County closed its county offices, and a community college closed all its campuses, partly for the Juneteenth holiday that fell during the storm. In Florida's Santa Rosa County, officials offered free sandbag filling at several stations, the same quiet preparation seen all along the coast. So the storm's effects formed a gradient across the Gulf states. The catastrophe centered on Louisiana. Mississippi took heavy rain, a dam scare, and the clearest storm-related death. Alabama and Florida saw flooding and power losses that lessened toward the east. The rain weakened as it spread, but it touched a remarkable number of states before it was done. Across that whole region, the deepest cost was not measured in inches of rain or numbers of outages. It was measured in lives, and it is to those losses that we now turn, plainly and with care. 4 people are confirmed to have died as a result of Tropical Storm Arthur. As of the count taken in the days after the storm, at least 4 deaths were attributed to it across the affected region. Behind that number are individual people and the particular ways the storm took them, and they deserve to be named in the plain terms the facts allow. In Texas, 1 person was killed by floodwaters in the town of Bandera, in the hill country west of San Antonio. Another drowned in a flooded retention pond near Houston. A retention pond is an ordinary feature of a developed landscape, a basin built to hold storm water. In a flood, such ponds fill and their edges vanish under the rising water, and what is normally a shallow fenced feature becomes a deep and hidden hazard. These 2 Texas deaths came from the storm's precursor and its early rain, before Arthur had even finished forming. In Mississippi, the road worker died during the cleanup in Franklin County, killed not by the storm at its height but by the dangerous work that follows in its wake. That death stands apart from the others in its timing, a loss that came after the rain had passed, during the labour of putting things back together. The 4th death is part of the same confirmed total, bringing the count to at least 4 as the region tallied its losses. Each of these was a person with a life and people who loved them, and the storm cut those lives short. The number 4 is small compared to the great hurricanes that have killed hundreds or thousands along this coast. But for the families involved, the number is not a statistic. It is everything. It is worth drawing a careful lesson from how these deaths happened, because the pattern is one that repeats in flood after flood. Most flood deaths come from water and vehicles, or from people entering water that proves deeper or faster than it looked. The 2 Texas deaths involved floodwaters, one in a town and one in a pond. This is the single most important piece of flood safety, simple enough to state in a few words. Turn around, do not drown. Do not drive or walk into floodwater. It takes surprisingly little moving water to sweep away a car or knock a person off their feet, and the depth and speed are almost impossible to judge from outside. There is a reason this advice has to be repeated every time. In the moment, floodwater across a familiar road looks crossable. The driver knows the road, has crossed it 1,000 times, and the water seems shallow. But floodwater hides the road beneath it. It can conceal a washout, a missing section, a current far stronger than the surface suggests. Many flood deaths are people who made a reasonable-seeming choice to keep going, and the water proved them wrong. Set against the deaths are the many rescues that did not become deaths, and these matter just as much to the honest account. At least 20 people were rescued from floodwaters in the Waco area of Texas alone. Around 38 were rescued across the Mississippi flooding. In Avoyelles Parish, where the record rain fell and roughly 100 residents were displaced, the rescue crews got everyone out, with no deaths and no injuries reported there. For every person the water took, many more were pulled to safety by neighbours, by rescue crews, by the National Guard. The displacement was its own kind of loss, less final than death but heavy nonetheless. Roughly 100 residents of Avoyelles Parish were displaced from their homes. Across the region, families left flooded houses for shelters like the one the Red Cross opened in Mansoura. They lost possessions and some lost the homes themselves, at least until they could be cleaned and repaired. A resident of the flooded community facing the wreckage put it plainly. They would just have to start over. The financial toll was estimated early at more than $100 million by a firm that tracks disaster losses. That figure will likely grow as the full damage is assessed and people return to count what the water ruined. But money is the easiest part of the loss to measure and the easiest to recover. The 4 lives cannot be recovered, and they are the part of this storm's cost that should not be lost beneath the remarkable rainfall numbers. The storm's human toll played out against an unusual backdrop, because the same region was in the middle of hosting one of the largest sporting events in the world. The collision of a deadly storm and a global celebration is its own small chapter in the story of Arthur. Arthur arrived in the middle of a party. That summer, the United States was helping host the World Cup, the global soccer tournament that draws billions of viewers and fills stadiums across whole nations. Several host cities sat directly in the storm's path, and the collision between a dangerous storm and a massive public event shows how a hazard ripples far beyond the flooded towns. In Houston, a host city, the effects began before the rain. Public festivals tied to the World Cup, the large outdoor gatherings called fan festivals where crowds come together to watch matches on big screens, were cancelled for one day and shortened the next as the storm approached. Cancelling a fan festival is a real decision with real costs. These events draw huge crowds outdoors, exactly the kind of gathering that becomes dangerous in heavy rain, flooding, and the threat of tornadoes. Holding one during a flash flood watch would put thousands of people outside in the worst possible conditions. A measure of how seriously the threat was taken came in Atlanta, another host city. There, fan festivals were cancelled, and a ground stop was issued at Hartsfield-Jackson Atlanta International Airport, one of the busiest airports in the world. A ground stop halts departures, holding planes on the ground because conditions make flying unsafe or because the airport cannot handle the traffic. At an airport that size, a ground stop sends delays cascading across the country and beyond, as flights that should have left sit waiting and the schedule backs up. The storm that flooded rural Louisiana parishes also reached into the air travel of a continent. The tension between the storm and the tournament came to a head over a specific match. A World Cup game between Portugal and the Democratic Republic of the Congo was scheduled during the storm. With heavy rain in the forecast, there was a real question of whether it could be played. In the end, the match went ahead and was not cancelled for a simple reason. The stadium had a covered roof. The roof meant the players and the crowd were sheltered from the rain, so the game could proceed even as the weather raged outside. That detail, a roof deciding whether a World Cup match is played, captures something about how modern infrastructure meets weather. A covered stadium turns a rained-out event into a routine one. The same storm that closed an interstate and flooded a town could not stop a soccer match held under a roof. It is a small illustration of how the impact of a storm depends not just on the weather, but on what people have built to withstand it. The collision had a logic worth drawing out. A storm's effects are not limited to the places where the rain falls hardest. They spread through every system the storm touches. Air travel, public events, transportation, all of it bends around the weather. A fan in Atlanta whose flight was delayed, a family in Houston whose festival was cancelled, a soccer crowd kept dry by a roof, all of them felt Arthur, though none of them stood in the floodwaters of Avoyelles Parish. There is a practical wisdom in how the events were handled. The festivals were cancelled and shortened in advance, before the worst weather arrived, rather than waiting and risking a crowd caught outdoors in a flash flood. The covered roof match went ahead because it was genuinely safe to do so. The decisions matched the actual risk in each case, neither overreacting to a sheltered event nor underreacting to an exposed one. That is what good risk management looks like, calibrated to the real danger rather than to fear. The World Cup chapter also shows the strange normalcy that runs alongside disaster. While rescue crews pulled families from flooded homes in central Louisiana, soccer matches were played and fans gathered under roofs a few hundred miles away. Both things were true at once. A disaster is rarely total. It floods some places and spares others, cancels some events, and lets others go on, all within the same region and the same week. That mix of the historic and the ordinary, the record flood beside the soccer match, raises a natural question. How rare was this, really? To answer it, it helps to set Arthur beside a storm from the region's own recent memory, a flood that people there still talk about, and to see how this one compares. To understand how unusual Arthur's reign was, it helps to set it next to a storm that the region remembers well. In August of 2016, central and southern Louisiana suffered a catastrophic flood from a slow-moving, unnamed storm system. That event, often simply called the Great Flood of 2016, dropped historic rainfall across the state, damaged tens of thousands of homes, and killed more than a dozen people. It is recent enough that many of the people flooded by Arthur lived through it. The 2016 flood shares a striking number of features with Arthur, and the similarities are instructive. It too came from a weak, slow-moving system rather than a powerful hurricane. It too dumped enormous amounts of rain over a short period on already wet ground. It too overwhelmed the slow drainage of flat Louisiana terrain. The pattern is the same. A weak but wet system stalls over Louisiana and rains until the land cannot hold anymore. That repetition is the real lesson of the comparison. Arthur was not a freak event with no precedent. It was the latest in a series of similar disasters, where weak, slow, water-laden systems produce flooding that strong hurricanes often do not. The state has now seen this pattern more than once in a single decade. The Great Flood of 2016 and Tropical Storm Arthur are two examples of the same kind of disaster, separated by about 10 years. Yet Arthur's peak rainfall stands out even against that recent history. The 2016 flood was a regional catastrophe, spreading historic rain across a wide area. Arthur concentrated an even more extreme amount, the apparent state record of more than 29 inches, onto one parish in about 12 hours. Where 2016 was a broad deluge, Arthur was a more focused and, at its peak, more intense one. The single location record fell to Arthur, even though the overall disaster of 2016 affected more people. Setting the two side by side also clarifies what the 1,000-year label really means. If a 1,000-year rain fell only once in 1,000 years, the region would not have seen two such extreme flood events within about a decade. The fact that it has tells us something. Either the region has been unlucky, drawing the rare event twice in a short span, or the underlying odds have shifted, making these extreme rains more common than the old records suggest. The honest answer is probably some of both. This is where the comparison turns from history to the present. The recurrence of these extreme rain events, two major Louisiana floods from weak systems in roughly 10 years, fits a broader pattern that scientists have been tracking. Warmer air holds more moisture, and the storms that form in it can carry more rain. The ingredients for a record flood, a wet system over warm water on saturated ground, may be coming together more often than they used to. It is important to state this carefully and without overreach. No single storm proves a trend. Arthur taken alone is just one event, and weather has always produced extremes. The 2016 flood taken alone is just one event too. But when the same kind of extreme flood recurs in the same region within a short time, it is reasonable to look at the larger pattern rather than treating each as an isolated surprise. The comparison does not prove anything by itself. It points toward a question worth asking. The people of central Louisiana do not need a scientific study to feel the pattern. Many of them have now lived through two historic floods in their adult lives. They have rebuilt once and face rebuilding again. For them, the question of whether these events are growing more common is not academic. It is the difference between a once-in-a-lifetime disaster and a recurring threat they must plan around. That brings us to the larger reason these floods keep happening, the conditions that make a weak storm carry a record rain. Understanding those conditions calmly and clearly helps explain why Arthur was not as much of an outlier as its record-breaking numbers might suggest. Why does this keep happening? Why do weak, unremarkable storms keep dropping record-breaking rain on this stretch of coast? The answer lies in a few physical conditions that have been shifting, and understanding them, without alarm, explains why Arthur fits a pattern rather than standing alone. The first condition is the temperature of the water. The Gulf of Mexico has been running warm, warmer in many recent seasons than its long-term average. We saw that the water beneath Arthur was above 83 degrees Fahrenheit. Warm water feeds storms and, just as important, warms the air above it. The warmer the Gulf, the more energy and moisture are available to any storm that crosses it, weak or strong. The second condition follows directly from the first. Warmer air holds more water vapour. This is not a theory, but a basic, measurable property of air, settled physics that has been understood for well over a century. For roughly every degree the air warms, it can hold a few % more moisture. Over a warmer Gulf, the air is loaded with more water than the same air would have held in a cooler past. When a storm wrings that air out, more rain falls. Put those two together and the result is a higher ceiling on rainfall. A storm of a given strength, crossing warmer water and carrying wetter air, can produce more rain than an identical storm would have produced decades ago. The storm need not be stronger. The wind speeds can be modest, as Arthur's were. What has changed is the amount of water available for the storm to drop, and that amount has been creeping upward. This is the quiet heart of the matter. The danger from storms like Arthur is not primarily about wind getting stronger. It is about rain getting heavier. The most damaging trend is not fiercer hurricanes, but wetter storms of every kind, including the weak ones. A minimal tropical storm today can carry more water than a minimal tropical storm of the past, and so it can flood places that a similar storm once would have spared. There is a third factor, which is the behaviour of the storms themselves. Some research suggests that storms have been moving more slowly in recent years, lingering longer over the places they affect. A slower storm reigns longer over the same ground, which is exactly the mechanism that broke the record in Avoyelles Parish. If storms are both wetter and slower, the two trends compound, raising the risk of extreme local rainfall. This factor is less certain than the basic physics of warm air and moisture, and it is honest to say so. None of this should be delivered as alarm, because alarm does not help anyone prepare. The measured way to say it is this: the conditions that produce extreme rain floods, warm water, moisture-laden air and slow-moving storms appear to be becoming more favourable over time. That does not mean every storm will break a record. Most will not. It means the odds of an extreme rain event have been shifting upward, and events like Arthur and the 2016 flood are consistent with that shift. For the people who live along this coast, the practical takeaway is steady and clear. The old assumptions about which storms are dangerous need updating. A weak tropical storm can no longer be waved off as just a rainy day. The strength of the wind is a poor guide to the danger of the water, and that has always been somewhat true, but it is more true now than it used to be. Planning, drainage, and warnings all have to account for the possibility that a modest storm will carry an immodest amount of rain. This is why forecasters increasingly emphasize rainfall and flooding over wind category when they warn the public. The category scale that ranks hurricanes by wind speed says nothing about rain, and rain is often the bigger killer. Arthur, a storm too weak for any hurricane category at all, proved the point by setting a state rainfall record. The lesson is to watch the water, always. With that pattern in mind, the question that remains is what comes next for the region Arthur flooded. The rain has stopped, but the water it left behind has its own slow story to tell, and the people there are still living it. The rain stopped, but the flood did not end with it. Water that falls in 12 hours does not drain in 12 hours, and the region Arthur flooded faced a long, slow recovery as the water worked its way out of the land. Understanding what comes after the rain is as important as understanding the storm itself, because the danger lingers long after the sky clears. The first thing to know is that the moisture did not leave cleanly. Even after Arthur fell apart, lingering tropical moisture remained over the southern United States, fueling more downpours across parts of the region for days. This is the tale of a tropical system, the damp air that hangs around after the storm is gone, ready to produce new rain wherever a weak disturbance or the heat of the day sets it off. For ground already saturated and rivers already swollen, even modest new rain raises the flood risk again. The drainage itself is slow by nature. The rivers and bayous of the flooded region run through flat, swampy terrain, and water moves through such country at a crawl. Forecasters warned that it could take many days, even a week or more, before the waters drop below flood stage on some of the streams, rivers and bayous. A family whose home flooded might wait a week before the water recedes enough to return, and longer still before the house is dry and safe. This slow drainage means the flood maps stay red long after the storm leaves the news. The dramatic phase, the rescues and the rising water, passes in a day or two. The recovery phase, the waiting and pumping and cleaning, stretches on for weeks. The roads stay closed, the rivers stay high, and the threat of renewed flooding persists every time a new shower passes over the saturated ground. For the people in the path, the standard safety guidance for a flood's aftermath is steady and worth stating plainly. Stay out of floodwater. It is not just deep and fast, but often contaminated, mixed with sewage, fuel and debris, as the fouled water in Mexico's flooded cities showed. Do not drive onto flooded roads, even ones that look passable, because the water hides washouts, and the road beneath may be gone. Heed the road closures rather than working around them. Listen to local officials about when it is safe to return home, and do not rush back before they say so. There is a particular danger in the cleanup itself, the same danger that took the life of the road worker in Mississippi. Returning to a flooded home and a damaged landscape means facing hazards that are easy to underestimate. There is unstable ground, downed power lines, contaminated water, and the simple exhaustion of hard labour in brutal heat. The heat index in the storm's wake climbed into the triple digits, making any outdoor work dangerous. Recovery work should be done carefully, with breaks, water, and attention to the hazards that remain. The forecasters also watched for the flood to spread to new areas as the water moved downstream. Rivers carry their water away from where the rain fell, and a river that is high in one place will be high downstream a day or two later. Communities that escaped the rain could still see rising water as the flood crest moved through their stretch of the river. This is why flood warnings can persist and even appear in new places after the rain has ended. The water is still travelling. Through all of this, the communities did what flooded communities do. They opened shelters, handed out food, and began the long work of recovery. Neighbours helped neighbours. A central Louisiana community, as one report described it, banded together after the flood. The resident who said they would have to start over was not despairing but stating a plain fact, the first step in a process that thousands of people in the region were beginning at once. The recovery would be measured not in days but in weeks and months. The water would drain, the homes would dry, the roads would reopen, and the damage estimate, already past $100 million, would settle into a final figure. The people would rebuild as the people of 2016 rebuilt, with the quiet knowledge that it might happen again. That brings us to the close, to a plain accounting of what this storm was, what is known and what is still uncertain, and what it leaves behind for the region and for anyone who watches the weather along this coast. So what was Tropical Storm Arthur in the end? It was the first named storm of the Atlantic season, a weak and short-lived system that never became a hurricane and never came close. Its winds barely reached tropical storm strength, and it fell apart within a day of getting its name. By every measure of wind and structure, it was a minor storm, and it appears to have set the single greatest one-day rainfall record in the history of the state of Louisiana. That contrast is the whole of it. The danger was never the wind, it was the water. A storm too weak for any hurricane category dropped more than 29 inches of rain on one Louisiana parish in about 12 hours, breaking a record that had stood since 1962, and earning, from the Weather Service, the description of a once-in-a-thousand-year event. The forecasters who said from the start that the rain, not the wind, was the threat were proven exactly right. Let us be clear about what is confirmed. Arthur formed on June 17th and weakened quickly afterward. The rain that fell over Avoyelles Parish was extreme, with totals above 29 inches confirmed by two separate offices of the Weather Service. The flooding overwhelmed towns across central Louisiana and spread damage through Mississippi, Alabama, and beyond. At least 4 people died. The damage was estimated at more than $100 million. These facts are solid. Let us be equally clear about what remains uncertain. The record itself was still preliminary, awaiting the official verification of the gauges by the Weather Service and the state climatologist. The 1,000-year label was a careful probability estimate, not a certainty, and the final figure could be refined as the data is reviewed. The full damage total will grow as the water recedes and the accounting continues. These are the honest edges of the story, the places where the final numbers were not yet settled. And what should a person watch for now? The immediate thing is the water still draining from the land, the rivers and bayous that may take a week or more to fall, and the renewed flood risk wherever new rain meets saturated ground. The longer thing to watch is the season ahead. Arthur was only the first named storm and it formed in June, early in a season that runs through November. A first storm this wet is a reminder of what the warm Gulf can produce, and there will be more storms to come. There is a larger thing to watch as well, and it is the pattern these floods trace. 2 historic Louisiana floods from weak systems in about a decade is a pattern worth attention, consistent with a warming Gulf and a wetter atmosphere that raise the ceiling on how much rain a storm can carry. No single storm proves a trend, but Arthur is one more data point in a story scientists are watching closely, and it is a story that matters most to the people who live where these storms come ashore. For them, the lesson Arthur leaves is practical and steady. Watch the water, not just the wind. Take the rain forecast seriously even when the storm is weak. Heed the flood watches, fill the sandbags, and never drive into water that hides the road. The people of Avoyelles Parish did much of this, and in the parish that took the worst of the rain, the rescues worked and no one there was lost. The warnings and the response saved lives, even as the record fell. Arthur is fading into the record books now, a weak storm with an outsized legacy of rain. The water it left will drain, the towns will dry, and central Louisiana will rebuild once more. The number it set, if confirmed, will stand as a marker of how much rain this coast can receive in a single day, a record waiting, as records do, for the next storm to challenge it. We will keep watching the Gulf, the season, and the sky, and we will be here with the next report when the next storm comes. Stay aware, stay ready, and take care of the people around you.